Alright, welcome back everyone. We're going to be doing another episode of PLC IO Sim. Please go check out their website. They also have a YouTube channel. And yeah, we're just going to continue on with the challenges that they've made for us. We finished off with number 11, the basic or tentative timer. And now we're just going to get started with number 12, the up-down counter. Let's see if we can get this sorted. Design a program to increment and decrement a counter. PB1 will increment the counter. When the counter is done, lamp 1 should energize. Pressing PB2 will decrement the counter. Pressing PB3 will reset the counter. Alright, so this should be fairly straightforward. We'll start with PB1 to increment the counter. So we'll use the count up function, tie it to counter 1. And then we'll use PB2 to decrement the counter, which is the count down command. And we'll also tie that one to counter 1. So let's just run and make sure that's working. So you can see the ACC is going up and the ACC is going down. So that's working. What else does it want? It wants when the counter is done, lamp 1 should be on. Okay, so the counter is done when ACC is equal to or greater than pre, which is 2, and then the lamp will turn on. And that's represented by this DN bit, counter 1 done. So we'll make a new line, and we'll add the bit for counter 1.dn. We'll add our light bulb. Go into run, and you can see ACC is above 2 and lamp 1 is on. Now let's try and go to a number smaller than that. So here's 1, 0, lamp 1 is off, so that's good. Now finally it wants pressing PB3 to reset the counter, so that should be easy. We'll just get PB3, and then we'll use the built-in reset command for the counters and give it a run. So we'll count up a couple times, turn on the lamp, count down just for the heck of it, and click reset. Good, ACC to 0. Just like that, fellas. I think it's time we try number 13, water tank 2, difficulty medium. Okay, design a program to fill and drain a water tank. Pressing normally open push button 1 momentarily fills the tank until the level reaches a normally open limit switch, high. Pressing normally open push button 2 momentarily drains the tank until the water level reaches normally open limit switch, low. Pressing the normally closed stop button at any time stops the operation. Okay, this should be fun. It's similar to the one we did in the previous video, but this time we're adding the stop button, I suppose. Okay, so it looks like we'll have to make some latching circuits for the filling and draining processes, so that when you press and release the push buttons, the operation continues. So if you remember how I did it before, we had our stop button in series with our 2 parallel contacts, and that was all feeding the output. We'll call that drain because the tank is full right now. And actually, yeah, this should work. Now this was the holding contact, and this was your energizing contact. And this was your stop button. So that when you press and release your energizing contact, when this command starts, this contact closes, and the sequence will continue to operate even without your button. So let's just verify that that's working. Click, unclick. And good, you see the drain works. However, I found out that there was actually another way to do this that's a lot easier. So let's take a look at that. Okay, so to make things easier, we can just use these built-in bits for latch and unlatch represented with a L and a U. And this will just make life a lot easier. So I'll show you what I mean. we'll just set it up like this. And we'll have to make a new line, PB2. This one will be unlatch for the drain. So the idea is, when I press PB1, as soon as this latch command gets the signal, it will enable and hold the drain command, even if I release PB1. So let's watch this. Oh, gotta go to run mode. You can see the drain command is staying on even though I let go of the button. The drain command is still on though, so to reset it we can just click PB2 and unlatch it. So that's just going to make life a lot easier for us, and that's how we'll be doing this from now on. No more holding contacts. Okay, with that out of the way, let's just get right to it. So in order to latch the draining process, we'll use push button number 1. Going to our latch bit for the drain. And now, in order to unlatch the draining bit, there's two things. We could either press the stop button, or we could use the normally open high limit switch. So a parallel set of contacts here will be able to unlatch the drain command. And I actually did this wrong. This will be fill. Push button number 1. So our first button could be the high limit switch, because once the water reaches the top, this switch will close, and therefore this contact will close as well, and then we'll unlatch the filling process. But we also want to be able to press stop, but stop is normally closed, so we have to use the normally closed contact here. Because if stop is normally closed, it's normally energized, this contact that is. So this contact will be open until we press stop. And that should be how we unlatch the fill process. Now we'll just copy this for the drain. Do PB2 for drain. Do latch drain. We'll add our extra rung there with our parallel contacts. The stop button will be the same. That will unlatch the drain. However, the limit switch, the low level limit switch, is normally open, but that's when the water level is below it. So when the water level goes down, 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 this switch will open, and that's when we want to unlatch the drain. So we'll actually, I believe, want to use a normally closed contact here as well. And we'll see if that works. Yeah, let's see. So PB2 for drain, press release. You can see it unlatched once we hit the bottom, so that's good. That means our low level limit switch worked. PB1 for fill, press and release. See this contact switch here. Beautiful. Now let's see if we can use the stop button. Beautiful. Looks like we're all good here. Okay, let's just go on to the next one then. Number 14, simple addition. This should be fun. Math is fun. Design a program to add two numbers. Pressing PB1 should add number A to number B and place the result in number C. Interesting. So we'll have to do some math here. Make an add box. And I guess push button 1 should go here to enable it. And then we just do the two numbers we want to add. So we'll add number A and number B. Those are the two sources. The destination goes to number C. And I suppose the way that we view this is just in the table on the left here. So it looks like they've set values number 1 and 2 to, or A and B to 2 and 3. So I believe if you're going to run and click PB1, we should get 5 in number C. Boom. just as I suspected. Now let's see if we can change these numbers. Cool. Alright, let's see what 7 plus 45 is. I have a gut feeling it's going to be somewhere around 52. Bang, displayed right here in number C. Would you look at that? And for our next challenge, we'll go to simple subtraction. And this should be lightning quick because I think it's the exact same as addition, but just the opposite. So we'll do push button 1 to subtract two numbers. We need to add the math box for subtraction. It wants us to subtract number B from number A. So I think source A will be like, it'll be number A minus number B if you do it this way. And then display it on number C. So if I'm correct on how this works, then it will do 5 minus 3, and it will say 2 for number C. So sweet, we got it there. Let's play with some values. Let's do 76 minus 444. I don't even know what that is. Look at that, negative 368. Isn't that something? Okie dokie. You can see that the next two is multiplication and division. We're just going to skip these because it's the exact same principle as the two we just did. You just get the box and put your numbers in it. So we wouldn't be learning too much there. So we're just going to try this one, which looks cool. Air compressor. So, design a program to control an air compressor. Pressing start momentarily should energize the motor and begin filling the tank. When the tank pressure rises and activates the normally closed high pressure switch, the motor should stop. Pressing stop should stop the motor at any time. Pressing vent should energize the valve solenoid and lower the pressure in the tank. Okay, first we're going to need to build a latching circuit to turn on the motor using the start push button. So we'll use our latching command to turn on the motor. And we'll need two ways to turn off the motor. One will be the stop button, make that normally closed. The stop button is normally closed. And for the pressure switch, you can see that it closes as the pressure rises. It will push up and close that switch. So we can use a normally open contact. So that way, once the pressure is high enough, this will close. And either of these commands will cause the motor to unlatch. Finally, we need to add our vent button, which is just a push button. Now when we're holding the vent button, the valve will activate and the pressure will decrease. So let's run and see if it works. Alright, so I'll do my latching start command. That seems to work. And we're going to see once the pressure gets to some sort of limit, this high level switch should close right here, and that should unlatch the motor immediately. So we'll just wait. There, 181 psi activates the high pressure limit switch. The only way to lower the pressure is to press this vent button, which will activate the valve. See, the pressure goes down. I'll vent it a bit more so that we can demonstrate the stop button. And now, yeah, we'll just double click the stop button here, and you can see the motor stops. So there you go, that's a good tank simulation for you. Alright, that's going to do it for our time limit on this video, but in the next one we're going to do level 19, which is the hard difficulty one, so that should be fun. And who knows, maybe we can finish all of them in the next video. We'll see. Anyways, yeah, smash like, subscribe, and have a nice day.